Okay, hello and welcome. Good afternoon. This is Monica Olson from the State Board. I'm the Accessibility Policy Associate. You are attending session or part one of a four-part accessible math series that I work to organize with Dawn Drouse here at the State Board. Um, and this session is titled, What is Accessible Math? And our purpose is for this session to serve as foundational um, a foundational starting point for those of you who are going to continue on in part two, three, and four. Right now, you see another picture of me on the screen. As I said before, I'm the Accessibility Policy Associate here at the State Board, and part of what I work on is helping to provide guidance and interpretation for accessibility best practices and requirements, particularly in response to the Title II updates of the Americans with Disabilities Act regarding web accessibility for our agency and the colleges. I am thrilled, absolutely thrilled, to be joined by my colleague and friend, Zach. Zach, I'm going to turn it over to you to introduce yourself.
Hi, everybody. My name is Zach Lattin. I work at Clark Community College as their IT accessibility coordinator. And I think more importantly for this presentation, I am a blind person with a degree in math from the University of Washington. Um, I like reading math books for fun,
Mhm.
and I read one last night when I couldn't sleep in order to get ready for this presentation. So I read Artin's Algebra, if you're curious, and I read chapter 13 about uh, ruler and compass constructions with fields. So anyway, um, I didn't put my email address on the slide, but I will put it in the chat if you want to email me or Monica. I'd be glad to answer questions about this stuff. So thanks for letting me come talk to you about math today, accessible math.
Thanks, Zach. And I took the liberty of putting your email address on this slide so people are seeing it right now. I hope that's okay with you. Oh, good. You're giving me the thumbs up. So before we move on to our first slide, folks, here's a couple of housekeeping reminders. We are recording today's session that will be shared out with the participants and the colleges. We do have the chat space enabled, and Don Drouse will be managing chat. There are a lot of us here today, so I'm going to ask a couple of things of you. One, please stay on mute unless you are raising your hand and unmuting to ask a question or share a comment. Two, we're going to try to refrain from clogging the chat box up with a lot of chatter. Sometimes that can distract and take away from the experience of people. However, I did turn on the Q&A feature for this meeting. For those of you who haven't used that before or not aware of it, you should be able to find Q&A and select and open that dialog box from the menu bar on the bottom of your screen. And so at any point in time, if you have a question that you need to get out of your body, but don't necessarily want to raise your hand and unmute, please put it in that Q&A feature because Dawn can track which questions we maybe naturally answer throughout the presentation, which ones we need to try to answer at the end during our discussion period. And then if there are any that we cannot get to, we can try to follow up later on. I think that's everything I need you to know. And here we go. So we're moving on. We're on slide 4 here, and we have a few disclaimers that we want to make everyone aware about this presentation before we get into the meat and bones. So for this presentation, Zach and I are specifically focusing on and talking about accessible mathematical equations. So there are some many other pieces of STEM content that are critical and important for us to think about from an accessibility perspective. And today we are primarily talking to you about mathematical equations. The other thing we'd like you to know is that the process, so the steps involved and the tools involved for making math and STEM content accessible depends on your source file. So what are you starting with? And we're going to talk a little bit more about that in future slides. So going from point A to point B and what that means and looks like. We must remember that every student has unique needs, and that includes every student with disability. And so, as much as possible, when we're thinking about how to create something that is accessible to a person with disability and assistive technology user, we need to consider their unique needs and the technology they're using or have access to. We're not going to cover AI tools in this session. Zach and I are aware that, various AI tools have entered the chat, so to speak, and are changing the landscape of how content is created and perceived by people, but that's outside the scope of today's presentation. And finally, we just don't have time to cover every possible unique workflow scenario or every single tool that someone could use to produce accessible math content. We're definitely going to be talking about some workflows and tools in today's session. And then for those of you who are continuing on in sessions 2 and 3 with Sean Jordanson, he's going to go more deeply into specific workflow scenarios for environments like Word, um, Canvas page, PowerPoint, etc. Okay, moving on, we do have some core objectives for you all today as our learners. We hope that you're able to identify tools and other factors that make math or STEM content accessible or not. Forgive the typo there and identify in number one, apologies. Two, consider the unique experience of students, so such as students using various screen readers and other technologies. We'll go into that a little bit deeper as well. Define MathML, LaTeX, their basic functions. Finally, we're going to help you articulate a list of do's and don'ts for making math accessible. We have a few core definitions that we'd like everyone to be on the same page with us as we go through today's presentation. And some of this might be review for you all, and that's totally fine. Um, so give me a little emoji or hand raise or something if you have heard of Universal Design, UD, spoken about it with a colleague, read something about it, maybe took a different class. Great. We're getting a lot of thumbs up and emojis, Zach. So that's great. That means you all are not starting from scratch here with us and you have some knowledge around universal design. Um, so the definition we put on the screen, I'm going to read it for you, and there's going to be some additional context Zach offers us. Universal design is a concept in which products and environments, so we can also think about a product or an environment, product as a mathematical equation, and the various environments those are going to be presented to students in. So a concept in which products and environments are designed to be usable by all people to the greatest extent possible without the need for adaptation or specialized design. So the idea of making something as accessible and usable from the get-go, out of the box, without having to go back and retroactively remediate content or fix something. AT or assistive technology, um, I love this definition that Zach gave me for our presentation because it varies from the one that I typically use and really centers the experience of the disabled person in my mind. So I'm going to read that to you now, and then we have some examples. After that, Zach, if you have additional comments, please jump in.
Sure.
So, assistive technology. Any way that a user interfaces with a computer, phone, or tablet that adds a layer of interaction between the user and the device that is not usually present for most other users. Then there's a list that provides you some examples of various software, hardware, um, um, AT examples. So someone might use the JAWS or NVDA screen reader, that's software. Someone may use Dragon Naturally Speaking, so that's voice command software. Someone might be using refreshable braille displays, hardware, or document cameras, hardware. Zach, I see you smiling. Any other comments you want to give on those two definitions?
Yeah, so I'm reading these slides with a refreshable braille display right now, but it's connected under the desk and I can't lift it. I'll show it. I'll get another one to hold so you can see it. But what I want to say about this is kind of my definition of assistive technology, and it's pretty academic. I've done a couple other math accessibility presentations, and we took this from that. And what I want to say is think about how often something goes wrong with your computer. Like, to take a recent example, I hope this is okay, Monica, but Monica doesn't have video because of some random little technical difficulty that happened that she wasn't predicting.
Mm-hmm.
Um, Anytime you add a layer of technology onto existing technology, that is another layer where something can go wrong. And that's kind of why I think of assistive technology this way. And especially when we talk about STEM accessibility, there are a couple more layers of things that we need to consider that can go wrong, or ways that content cannot be accessible for assistive technology users. So I just wanted to say, to add that context to this really academic definition and explain that that's why that's there.
Thanks, Zach. And I appreciate your definition a lot. Definitely got me thinking, differently and deeper when we were preparing and practicing yesterday. Term three, optical character recognition, OCR. No, we are not talking about the Office for Civil Rights. We're talking about optical character recognition. This is the process of converting images of text or math into selectable and discoverable real text. So you all are probably familiar with a scanned PDF. That's not real selectable text. That's a picture of text. So if you put that document through the OCR process using a tool that performs OCR and turning it into real text, you have OCR'd that document. And that's a turn of phrase you'll hear in the accessibility world quite often. GUI, graphical user interface. And before I move on to our next screen, I realize I forgot to put our sign-in sheet into the chat. So I'm going to go ahead and copy paste that now. And I ask that you try to uh, log in and sign in, because I am wanting to have a reflection of who attended today. So here you go. Here's that link. Hopefully that works. And if it doesn't, Dawn, you can let me know. Okay, we're moving on to the next slide. Excuse me. Okay, slide 7. Start with a universal accessible design approach. So yes, we're specifically talking about mathematical equations and what needs to happen for those to be accessible in a Word document, for example. Likely there's going to be other content on that page, and there are accessible design best practices that you should be aware of and thinking about as you're focusing on your STEM content. So having accessible STEM content's not going to go very far for a student who's using a screen reader, for example, if for example that document has really poor heading structure and they cannot navigate that document easily, or has a list of 100+ inaccessible hyperlinks and they cannot distinguish which hyperlink is going to take them where or whatnot, etc. So if what I'm saying doesn't feel like review for you and you're like, huh, what is Monica talking about in terms of um, digital universal design or accessibility best practices for design, then I refer you to these two resources. Hyperlinked on this screen, we have the SBCTC Library of Accessibility Resources, and there's a specific module titled Accessible Design Concepts, and it's going to go over those core things we want you all to be aware of and thinking about we're going to cover those on the next slide. The second resource is from the University of Washington. They have a lot of great guidance as well on their IT accessibility web pages. And so the link I provided you is the UW Accessibility Basics. And so they're going to give you a lot of the same content that you can find in the SBCTC micro courses as well.
Hey,
So
Monica.
Monica,
Yes.
So, sorry, the file you dropped in, none of us are able to open it.
Okay, I was wondering if that might be the case. I'm not gonna get hung up on that right
Okay.
now and take away time. So we'll move
if
on.
you want, I could take the next slide and you could troubleshoot or
Yeah, let's do
you want to
that.
do that? Okay.
Yeah, okay, cool.
Okay. So yeah, just to keep going on what Monica was saying, we're on slide 8, and this is kind of the universal design, just basics of universal design, which again, there's a lot of layers to math accessibility, and this is the first layer, is meeting the basic universal design guidelines. So we want to make sure that documents or the content has a semantic heading structure. I'll do some demos later on, and I'll demonstrate what it's like to navigate things with headings with a screen reader. We want to make sure that tables have properly assigned row and column headers. And a lot of times people just say headers or headings in a document, and they might mean table headings or heading levels, which are very different in the universal design digital world. And then we want to make sure that tables are used for data and not for design or layout. If you're in Microsoft Word, it's okay to use layout tables in HTML. We want to make sure that images have alt text that is meaningful. And I'll say that describing STEM images could be a whole nother presentation. So we specifically decided we weren't going to talk about that, but there's a lot to say there. We want to make sure that link text is descriptive. So hyperlinks have, you're not saying click here to go to my survey. You want it to say click on the survey, and then the survey is the link, so that it's descriptive text. And universal design would encourage you to stay away from pasting the text of links into documents like http://. They would want you to include descriptive text. And then, of course, we want to make sure that we have list structure. If you have a list of something, you want to semantically tell whatever system you're building that in that it's either an ordered or an unordered list. And I can demonstrate why that is. We might see that in some demos. And then we want to make sure that things have good color contrast. 4.5:1. If you're a fan of web content accessibility guidelines, want to make sure that you have good text foreground to background color contrast. And you want to make sure that your documents have generally good font size and readability. So that's kind of a really fast overview of universal design. Again, there are resources on the previous slide. If you have more questions about that. So moving on to slide 9, I'll talk, if it's okay, I'll keep going, about the definition of accessible math. And I want to say here that, universal design and accessibility, when we usually talk about it, there's something that we can point back to in web content accessibility guidelines. Like that is our source, that's our Bible for accessibility. But with STEM and math accessibility, there's not necessarily something in WCAG that says math has to be made accessible in this way. We need to make stuff be perceivable and operable and understandable, but it's not as precisely defined. And so for me, this is kind of, again, another definition from my life and world. Math content is accessible when an assistive technology user with the necessary background to understand the text and images can get the same meaning and context out of the content that their non-assistive technology using peers can get. So, the example there is you can make an abstract modern algebra book accessible, or a book about groups and rings and fields. And that doesn't mean that anyone can read and understand the content. It means that someone with a background in math can understand that content on the same level as a comparable person who doesn't use assistive technology. So a lot of times people get hung up on this. And I just want to say that, again, it's a little bit different, and it could depend on the student's needs, or it could depend on the level at which you're teaching or creating the content. So, but the most important part of this is that numbers, symbols, and their hierarchical and semantic structures are navigable by assistive technologies. So I know there's a lot going on in there's a lot of technical difficulties going on, but maybe we could pause, and because this is like the most important thing I think this is what, if you take one thing away from my content, it's this thought experiment that we're about to do. So if you are a math educator, which my understanding is that most people here are faculty who teach math, I want you to think for a second about how you read a page that's full of equations. And I want you to, maybe one or two people can paste in the chat. Do you read those equations from top to bottom, from left to right and top to bottom? Or do you read them left to right and top to bottom? Okay, so you do read every single equation left to right, top to bottom. That's okay.
You've got
Okay,
another
we got
comment.
someone else who said they look at the overall structure first.
Yep.
And I think that the way I was trained when I got my degree in math is eventually everybody was seeing, the quadratic formula, to take the example that we're going to talk about. Yeah, so we got another, we read those equations hierarchically, or we read them a little bit differently than we would read a novel. You don't just sit down and read a math book like it's a novel. You read it, you kind of read the equations hierarchically, and you go back over them, and you maybe realize, if you're looking at a big fraction, you might notice that some terms can cancel. And the other thing that I want everyone to kind of consider is, and this is really, really, I've told this story at other sections. This came up as an argument at my wedding between two accessibility specialists. And the question is, if you had a math book, would it be acceptable to read verbal descriptions of the equations? Would you be able to parse a math book that had not the equations, but verbal descriptions of all of the equations? And I think that the answer for most professional mathematicians who weren't born before we had mathematical notation in a monastery or somewhere, where we used to use narrative writing to talk about our math, but we stopped doing that in about 1200 AD. And we got a lot further along in our understanding of math. So why is it okay to, and we'll get into this, but it shouldn't be okay to put descriptions of equations in image alt text. We need to give assistive technology users the same ability to read math in the way that you're, as a professional, used to reading math. Sorry, I sort of rushed it because I feel like I want to get through all the content because I'm excited, but hopefully you can start to think about how you read math and how you can give somebody the same equal access to that experience.
And you've got some people agreeing in the chat of like, oh, that would be so hard if it was just a description of the equation. Some people saying, oh no. Others saying it depends on the complexity of what you're trying to read. So you're getting some
Yes,
responses there from your thought
yes.
exercise.
And we got, so hang with us, friend, because we have ways to put math into Canvas in an accessible way. I'm noticing that comment.
Yes, yes. Also, good reminder to put specific questions in the Q&A feature so we can keep track of those and which ones we answer and which ones we don't. All right, are you ready to move on to the next slide?
I am so yeah, so we're gonna do the first demo right now.
Yes, we
And
are.
this is going to be a demonstration of a little bit of how a screen reader works and a demo of how math works if you're using a PDF document. So I'm gonna start sharing my screen and my audio, and you're going to hear your device start talking because I'm using a screen reader. And so you'll might get a little, if you've never heard a screen reader before, you're going to hear it. And the other thing I'll mention is that there's a lot of content being posted in Zoom. And if you post while I am sharing my screen and audio, there's a chance that the screen reader will read what you're saying. I do try to mute that, but you know, I guess if you want to say something to the world, now's your chance.
Or choose not to put something in the chat while we're listening to Zach's screen
That's
reader.
my that's
Screen sharing meeting controls window.
um this is kind of
Show thumbnail video. Selected alert.
what a
Meeting
screen reader
control has been
sounds
docked to
like.
the bottom alert.
And I get all
The
kinds
video
of
thumbnails are
notifications
minimized to
about Zoom.
optimize for video sharing alert. Participants can now see your screen. Press F6 to view pop-up alert.
Okay, so this is like, Zoom is one of my least favorite things because of how
Desktop.
chatty it is, and I'm glad that 2020 is over. But when you have a screen reader
Start
running, you can use the operating system with a keyboard. So if I press the down
Pinned
arrow,
list. Microsoft Edge 1 of 15.
it's telling me Microsoft Edge 1 of 15. So I know I have 15 icons here.
Photos 7 of 15.
And I can kind of navigate my computer with a keyboard. So this is incidentally why keyboard accessibility is important.
Desk.
So what we're going to do
091
to
review
open
4.pdf.
this amazing Math 091 review.pdf document
Edit
in Adobe.
091 review 4.pdf. Adobe Acrobat. 32-bit. AV page view text frame.
And it didn't start reading like it did when I did this before. What is happening? It's my turn to have some technical difficulties. So this PDF, if you ran it through an accessibility tester,
Screenshot 091.
it would not have any errors. It's got heading levels and list structure.
Review 4.
But this is what NVDA reads if we read this.
Blank. Multiple choice. Identify the choice that best completes the statement or answers the question. Blank. 1. Simplify the expression, if possible. Blank. 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 A, B, C, D, E does not simplify.
Okay, do you think you could complete that question with that, given that information?
Blank.
On to number 2.
2. The average cost, in dollars, for a company to produce child car seats is given by the formula. Blank, blank, blank. Find the company's average cost to produce a car seat if 2,000 are produced. Blank. A, B, C, D, E. Blank.
Okay, I hope you got the answer to number 2 too, if you're just listening. And not to be flippant, but this is pretty standard fare for PDFs with math in them. They'll skip the equations and they'll skip all of the expressions. And if there's a big fraction, it just won't read it. So you want me to do anything else with this demo, Monica, before I stop sharing my screen?
No, I think that gets the point across
Okay.
Screen
that
sharing, mute,
these
stop share.
inaccessible math equations in PDF don't give you any useful information. We heard blank, 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 blank.
Yeah, it's the story of my life in college. I had a lot of PDFs like that. Um, okay, so and yeah, feel free to post questions in the Q&A, and I think we can get to them. Okay.
Okay. And are folks seeing my screen again now? I've reshared. I need a confirmation. Great, thank you. Okay, so, here are some factors to consider when you're, especially, when you're taking something that's inaccessible and we're gonna work to make it accessible. How was the content created initially and where is it located? So is it handwritten math on a piece of paper that's being, scanned and uploaded for students to look at? That's going to be a picture of handwritten drawn math. Is it a PDF document or a scanned document? We just saw what happens with inaccessible math equations in a PDF document. Maybe it's a screenshot of something on the whiteboard, and where is all of this going? So how are students accessing it and being asked to look at it? Starting and ending file types. Again, we're going to talk a little bit more specifically about that. Available tools for remediation. I want to point out that some tools we mentioned today, you are going to have access to at your college, and some tools that we mentioned today, you may not have access to right now at your college because it's a third-party tool that requires licensing. Um, if that's the case, Dawn and I urge you not to get stuck there in a moment of frustration, and know that Dawn and I are going to have some further conversation at the state board around maybe what we can do as an agency to support system-wide access to these critical tools to support accessible math equations. So that's something I wanted to say right now. Web browser versions plays a role for the student experience. I think Zach's going to say a word or two about that as well later on. And then also thinking about the end users' tools and their unique needs. Okay, we're now on to slide 12. What is LaTeX? That's you, Zach.
Yeah, so we're going to talk about LaTeX because I talk about that in every math session. So it's, if you've heard of, some people pronounce it differently, but or some people call it tech, but LaTeX is a document preparation system for high quality typesetting designed for the scientific and technical communities. It is designed for the print world. So, this was invented in the 80s. It is the de facto standard for the publication and communication of mathematical scientific notation. It is written by humans and it's meant to be human readable. And as such, if you're a screen reader user, you can learn to read LaTeX. So screen readers just can read LaTeX. Because yeah, actually, LaTeX is my love language, believe it or not. So it makes my heart happy too. I personally really like LaTeX, and it's human readable. The only thing is that the semantics and that hierarchical way of reading will be excluded. So what we will demo in a bit is there's some things that aren't possible, but as technologies go, LaTeX is pretty great if you can train a student to use it, or if a student is familiar with it, or you'll talk about this in more sessions. This is just the intro. So we have an example of LaTeX, and it's the quadratic formula. I can read it out real quick. It's $. LaTeX always has $signs on either end of it. X equals backslash frac, open brace, -b, backslash PM, backslash SQRT, left brace, B caret 2 minus 4 AC, right brace, left brace, 2A, right brace, $. And if it's very easy for me as a person to keep track of those braces and realize that I'm in the numerator of the fraction now. But that took a lot of practice. And so then on slide 14, we have a rendering of what that looks like. So those of you who are familiar with LaTeX workflows, you might know that you can build. Yes, people love to talk about their dissertations when I bring up LaTeX, and it just makes me so happy because yes. And so if you use a tool to render your LaTeX into PDF, you'll get the pictures. You'll get nice images of the equations, but those equations won't be accessible. We're going to talk about some ways to make LaTeX into more modern accessible stuff in a little bit. But if you have your LaTeX source files for your content, that's a great start to making your content accessible. So anyway, that's a picture of the quadratic formula. Okay, so now we're going to talk about math markup language. So MathML is a computer markup language. The ML stands for markup language, like HTML. And it's a low-level specification for mathematical and scientific content on the web. So this technology was originally designed for the web. It was designed for the digital world. It is not meant to be written by hand. So those of you who might have written HTML by hand, MathML is not like that. And that's important because I've met people who have tried to write MathML by hand and it doesn't work. We'll show an example of that. It's usually generated using an equation editor or some kind of graphical user interface. Canvas has one. I'm just going to plug that. And the two that Canvas has, there's actually two, and they both make accessible MathML. So the person who writes stuff in Canvas, you might want to look into the Canvas equation editor because that will spit out accessible math on the other end. And you can also, I'm just going to say this, enter it in LaTeX and have it convert to MathML. So the one caveat to MathML is that I put the ISO standard on this slide because it isn't compatible with all user agents. So some versions of Chrome, I don't remember where we are in this argument, but some versions of Google Chrome don't have built-in abilities to display MathML, and some screen readers don't have built-in abilities to create to read accessible MathML without adding something onto them. So if you want to research whether your user agent is going to be compatible with MathML, this is the ISO standard that you can look up. Here on slide 16 is an example of.
Before Zach,
go
I'm
ahead.
butting in. Before we go to
Yes.
16,
Definitely.
I was just taking a look at our Q&A, and there's one question about LaTeX I'd like to ask if that's okay, or do you prefer I just wait? Okay.
Yeah, it's great.
And it's in direct response to a comment you made about LaTeX towards the end of that slide. So this participant asks, so the LaTeX code is accessible, but the rendering of the code into the equation is not accessible? Question mark.
Yeah, that is a great question. So if it renders into a PDF or an image, it's not going to be accessible. But if you render it into MathML, it will be accessible.
Thank you very much. I'm going to mark that as answered.
Okay.
Okay, awesome. Now we're going to move on to slide 16.
Okay, so here's an image, and we don't need to dwell on it really, but this is what A sub 1 plus B sub 1 looks like in MathML. And it's so big that on our slide, we had to make an image of the text, which you should never do in the universal design world, but it's just kind of an example of what we are talking about when we say we can't write MathML by hand, but math type Canvas equation editor. If you have some really great weird LaTeX compiler that I don't know about, basically you should strive to get your stuff into MathML. So
And we're going to move on to the next slide
yes.
here, which is 17. And this is technologies that create accessible math ML. So these are the technologies we want you to be aware of that are going to help you create accessible math ML. So there's math type. Some of you may have access to that already, and some of you may not. Office 365 equation editor. So that's the equation editor built into Microsoft. And then also the Canvas equation editor supports MathML. We do have a couple of MathML/Canvas related questions in the Q&A. I'm wondering if we could visit those now or if we want to keep moving along. What do you think, Zach?
I think that we have 5 minutes for questions, and then we could do the demo.
Okay. Yeah. So you're saying it's okay to pick a couple?
Definitely.
Okay.
Yeah.
Okay, so there's two participants that have some similar concerns about MathML being supported inside Canvas messages. So not the actual 8 pages or assignments that or discussion posts that students are engaging with, but the messaging inbox system.
Oh.
So, and I think they're saying that this is not currently possible, or asking if we know. Do
Yeah.
you have insight on that?
Yes, I've overlooked that little technicality. So the can the discussion going on about the Canvas inbox being inaccessible is truth.
Okay.
I discovered that this morning, in fact. So what I would say is anywhere where you can only enter text is not going to have that Canvas, that MathML LaTeX accessible math option. And you will have to go back to 1200 AD and be someone in a mind, be Pythagoras, writing out your stuff verbally. So I forgot about that little hiccup. Yes.
But that's a good hiccup for us to be aware of and acknowledge in the room today. And before we move on, for the two people who put that question in the Q&A, did we answer that? Or did I not interpret your question correctly? You could say yes in the chat. Yes, answered. Great. Okay, we're gonna go ahead and move on to our next slide. Thanks, y'all. Okay, so slide 18, technologies that read accessible MathML. So we're talking about people who are using various assistive technologies to read the accessible MathML to them. So there's the NVDA screen reader with the MathCat add-on feature, which I believe earlier you were using NVDA for your demo. Is that correct, Zach?
Yes. And we can talk a little more about it. Like the MathCat add-on is only going to read accessible math. It won't magically make PDFs accessible. So, but yes, I
Okay.
was using NVDA screen reader.
Yep. VoiceOver screen reader, which is, excuse me, Mac OS and iOS. And then there's JAWS screen reader on Windows. Okay, now we've come to demo number 2, where Zach's gonna give you a more accessible experience of accessible math on a
Yes.
webpage.
And I'm getting set up for this. Right. Sorry, it's taking me a second.
That's okay. I'm gonna stop screen sharing now.
Okay. Yeah. So this demo that we're going to do is with NVDA, the NVDA screen reader, which is a free screen reader. And it is, I have the MathCat add-on installed, which is a little bit, setting that all up is beyond the scope of this presentation, but uh, you have 3 more sessions. So, okay. So
Stop share.
So this is
The
and
video thumbnails.
Neil Soifer is the guy who made the MathCat add-on,
And
and
again,
he does this amazing thing when he
linked
presents. He asks the audience to give him a random math topic from the web, and he Googles it. And there's so much accessible math on the web now that it's likely to read it. Random content on the web. I'm not that brave. So this is the Wikipedia article for the quadratic formula. And just to show you a little bit about the importance of heading level navigation, if I press H with my screen reader,
Contents navigation landmark contents heading level 2.
I'm sorry. So I'm going to turn the speech viewer on this time so you can see
Speech viewer.
quadratic what's going on, because this demo is, so hopefully you'll be able to see what it's saying also. And later on, if we get really brave, we can turn on the Braille viewer and I can maybe show you some Braille. So
list with 8 items link, top.
So you heard table of contents, and then you heard list with 8 items. So that's why it's important that that list structure is there, so that I don't care about this list, so I can skip right
Main
past
landmark
it.
quadratic equation heading level 1.
And I get to another heading level 1.
Solving the quadratic equation factoring by inspection heading.
I can navigate this whole article.
Completing the square
by headings.
Quadratic formula and its derivation heading level 3. Reduced quadratic equation heading level 3.
And so if I care about the quadratic formula and its derivation, which should have a lot of equations in it, and this was a moment for me in 8th grade when I learned about the derivation of the quadratic formula. That was when I was like sold on this math thing. And it still kind of gives me chills if I read like the proof, the algebraic proof of how it's derived.
Main article, link quadratic link completing the
we will look for some equations and I'll show you how MathCat
called the quadratic formula. Easily be seen, by link polynomial expansion, that the following equation is equivalent to the quadratic equation. Open paren. X plus B over 2 A. Close paren squared, is equal to, the fraction with numerator, B squared minus 4, A, C, and denominator 4, A, squared. Okay, so that was a lot of content. And if we wanted to, the way that this hierarchical navigation that I've been preaching works is I can press open paren. X, math.
The enter key on this entire equation, and it says math, which means that this part of the screen reader is engaged, and now I can arrow left and right.
Is equal to.
And I can get.
Open paren. From Jason Malitzi LCC math he/hims.
Okay, so we can't post in the chat while this demo's happening, sorry.
Is equal, open paren. X plus B over 2. A, close paren squared.
Okay, so like I got that, X plus B over 2A quantity squared. So I guess I could go move on and I could press the right arrow.
Is equal to.
There's the is equal to sign, and then.
The fraction with numerator, B.
It says the fraction with numerator B. And so I know already like, okay, this is going to be a big fraction. I can zoom into this fraction.
In numerator, B.
And I can hear
squared minus 4. A. C.
I can hear in numerator B squared minus 4AC. So that's
in denominator 4. A. Squared.
And there's 4A squared in the denominator.
End of math.
And it actually, if I wanted to, I could.
In numerator, in denominator.
I could zoom in a little bit more into this denominator and I could say, oh, there's the 4.
A.
There's the A.
End of math. 4. A. Squared.
And there's the A squared term. And if I wanted to zoom in more to the A squared term.
In base. A. In exponent. 2.
And I can hear in base, in exponent 2. So that's kind of.
Randy Anderson has left the meeting alert.
That's kind of the way that this hierarchical navigation works.
Out 4.
I do also want to mention the other important thing about this is that
NV
If you are a Braille reader,
view log. Speech viewer
you're
checked. Braille
actually
viewer.
getting this
Quadratic.
output in Nemeth Braille. So you're not getting the words that you're hearing on this the screen reader say, you're getting the equations in Nemeth Braille or Unified English Braille.
Space.
And that looks like
Open paren. X. Plus. B.
that looks like that.
Over 2.
Hopefully, if
A.
you
Close.
can see, you can read the Braille on the screen, and that's Nemeth Braille. So that's different than the words appearing on the screen, which is not how most people read math. So that's all I wanted to demonstrate. But before I stop sharing my screen or sharing my audio, are there any questions about or anything anyone wants to see? Or Monica, do you have any questions about this?
Thanks, Zach. I hope that that demonstrated for people the the different experience you had as a screen reader user, being able to hear and navigate the math on this web page, driving home the importance of the accessibility behind the math. So I don't have any follow-up questions, but certainly if anyone does or wants to hear something again, now's your time. You can unmute or raise your hand feature. I don't think I'm
Awesome.
seeing or hearing
Screen
anything.
sharing.
Yeah.
Mute. Stop.
So we will. Oh, in the Q&A, there was a question that I think might be good to ask now. For the Braille and NVDA for math, we need the MathCat add-on, correct?
Yes, that's a great question. Yes. So if you're using NVDA, you need the MathCat add-on. JAWS does it by default and will output Nemeth Braille by default. VoiceOver on the iPhone, if you go into the settings and configure it, will give you Nemeth or Unified English Braille.
Thank you, Zach. Another question I want to address from the Q&A. I know this isn't the focus of the discussion, but will we be talking about graphing and ways to make graphs and graphing ideas accessible? Thank you, Dan, for your question. It's out of scope for today's presentation. We may get to a little bit of it in sessions 2 and 3 with Sean Jordanson, but I'll say now that Dawn and I are in some early phase discussions of repeating this series for folks winter quarter and adding in potentially adding in another session that's more specific to complex images, etc., that students need to be able to use in STEM. So don't have a, bulletproof answer for you right now, but that's what I got.
Can I say one word since it seems like we have a little bit of time?
Yes.
Sonify the graphs, sonify data, which you could Google probably, but a lot of there's ways to make graphs accessible. So yes.
Thanks.
Yeah.
Okay. And I see another comment in the chat that says, I need help with images. I teach geometry. Okay, so we're nearing the end of the content of our presentation, and we'll get to more questions and discussion shortly. Here are a list of things that we do not want you to do moving forward after today's presentation. Use pictures of math.
Monica, do you think you're
yes.
sharing your screen?
Oh, I'm sorry, I'm not. Thank you. Appreciate that. Just a second. Okay, are folks seeing the screen now? I've got some people saying yes. Okay. I'm not sure what's going on for the folks who are saying no. I'm sorry. So we don't want you to use pictures of math. So things like screenshots and scanned documents. We even included an example of what not to do in this very slide deck earlier. Present handwritten math and PDF documents. Publish math and PDF documents, period. So PDF is not supportive of accessible math. Word and Canvas are going to be the way to go here. Assume that all users have the same needs or use the same AT. Use vendor products that deliver inaccessible math content. So here we're talking about third-party publisher platforms and text materials. So we all may be using, a variety of different third-party publisher materials and textbooks. It's a little out of scope for Zach and I to go down this particular rabbit hole super deep right now. But it's important to think about, how that content is being generated by the content creators and the publisher before you adopt that material and put it into your classroom for your students. Otherwise, they won't be able to use it, and a lot of retroactive remediation is going to be required. Instead, do these things, and hopefully we've done a good job demonstrating some of these things to you today. Publishing math content in Canvas pages instead of PDF documents. Putting math content in a Word document using MathType or the built-in Microsoft equation editor. Using the various tools we discussed earlier that produce accessible MathML. Keeping your LaTeX source files. Zach spoke earlier about the usefulness and benefit of having LaTeX, especially if students are familiar with LaTeX and can use it. It's important to go check what version of Microsoft Office you're using right now. The latest version has the most accessibility support. Whenever possible, consider the specific and unique needs of the students that you're teaching and working with. So sometimes this may mean that depending on a particular scenario, your subject and the student's access needs and their technology, the technology that they're using may mean that some early conversations between you, the student, and the Disability Services Office are going to be required to make sure you all are in agreement of the correct process and workflow and output that that student's going to need. So we've given you a summary of things to do no matter what to make your math equations more accessible. And there still might be some unique scenarios depending on the student that require more in-depth conversation with your accommodation office. And that's something we wanted to flag here as well. Okay. For those of you who are joining us for part 2, our next session is with Sean Jordanson. He calls himself the accessibility guy. And that session is Accessible Math Part 2 for Canvas and Word. That is October 21st from 3 to 4:30 p.m. and it is also on Zoom. Okay, that brings us to Q&A and discussion time.
Can I just address this question in the chat about HTML5, Monica? Or
You can do whatever you want, Zach.
okay, so I want to say that let me read the whole thing, but this has happened to me. I can't read the whole thing.
Is it
Let's
though
see.
pretty long?
Yeah, if I'm understanding it correctly, I think what we need,
Would you like the person who asked the chat to unmute and ask the
sure,
question? If they're
yes,
still here?
because this
So,
is really important.
okay.
This,
So Margaret, if you're still with us, do you mind sharing your question out loud?
Sure. So I'm asking on behalf of our faculty, and he encounters the issue where when he successfully converted that LaTeX to HTML5, and which is accessible by screen readers. And he also ran the accessibility checker and Canvas, and that passed. But when he used the screen reader to actually read the HTML document output, it's reading it incorrectly. And there is a example in the chat.
yes.
Yeah. So
Yeah, so I want to say a couple things about this. One is HTML5 is accessible. And the Canvas accessibility checker is going to say it's accessible, but it needs to contain MathML. And the 24, the fact that it's saying 24 tells me that something's going wrong in the MathML layer of this. So I don't know if it's this is the part I was trying to figure out, but if the person is pasting LaTeX into Canvas and converting with the Canvas equation editor, that's significant, and we should put in a feature request to Canvas. But if they're using another tool that isn't vetted, it may not be putting out accessible MathML. We're not looking for HTML5. We're looking for MathML inside the HTML5. So I hope that, I don't know if that answered your question, but the other thing to consider possibly is, was the screen reader a version of a screen reader that supports accessible math? So for example, older versions of JAWS have problems. NVDA without MathCat won't be able to read it. Microsoft Narrator cannot. Older versions of iOS, I trained a student this morning who can't afford a new iPhone and doesn't have a newest, latest, and greatest version of iOS, which is something we deal with in community colleges. So think about all the layers. That's why I wanted to highlight this question, because it points out the layer factor here.
Margaret, did that help answer your question, or at least give you a place to start with the faculty you're working with?
Yes, that's very helpful. Thank you so much.
Awesome. Great. So we've got, I think, 7 open questions in our little dialogue box here. And I think we could kind of just start from top to bottom. Dawn, can I ask you, I'm going to hand it to you for a minute. I need to step away to get some water. Would you mind reading the first question? And Zach, I'm going to put you in the hot seat for just a minute or two until I come back.
Okay, I hope I know the answers to these.
Okay.
All right.
Okay, Zach,
I'll
our
be right
first
back.
question is, sometimes links get broken or don't work. How can students get the address to manually go there if they need to? I think this is in reference to making sure you have descriptive hyperlink text.
Yeah, so that's a little beyond the scope of this presentation, but that if links get broken, if the thing behind the link that it's pointing to is broken, then no one's going to be able to access it, assistive technology user or non-assistive technology user. So that's actually technically equal access under the Americans with Disabilities Act.
I think
I don't-
also,
yeah.
The idea is that I'm guessing for this anonymous participant that they're talking about spelling out the website so that students could then type in the name of the website.
Oh, no one's asking anyone to spell out the website.
Okay,
So we're asking you to, instead of putting http://www.google.com, to put the word Google and then format that word as a hyperlink that you can click on.
Okay.
Yes.
okay. Our next question is, how would a blind student turn in their handwritten work for a test? How would it be generated?
I love this question so much, and it's a little beyond the scope of our session, but there's a couple options. One is they could learn LaTeX. And I realize we're not asking all of our community college students to learn LaTeX. So that's the option that I'm most familiar with. But now there are technologies that allow blind students to write their math in Braille, in Nimith Braille, and have it print out accessible MathML. Examples of such technologies are the Braille Note by Humanware. I think JAWS might have a Nimith math entry mode now, and I believe that you can enter Braille on an iPhone, but I haven't tried it. The other thing to remember is the good old-fashioned Perkins Brailler. if the student came through the K through 12 world and is used to showing their work in Braille, maybe they can show their work in Braille in college, and disability support services can pay someone to transcribe that Braille to print. So those are my top 4 or 5 options.
The pretext markup language authors claim that their output to HTML is accessible. Do you know if this is accurate?
I am going to plead the fifth on this question because I don't know what the pretext markup language is.
Okay.
But I will say there's a caveat where we're specifically not talking about a lot of third-party tools that authors or publishers use, because those aren't necessarily accessible, and it's a wild, wild west. So yes.
Okay. How and when did you learn how to use assistive technology like screen readers? It seems like it's definitely a special skill set with a learning curve. Is it something that students might learn at a young age?
That's a big question. It really depends on the student, and I don't have time to tell you how and when I learned it. But I've been doing it since the 80s, maybe since the early 90s. And so what I would say is, if a student is struggling with being proficient at assistive technology or screen readers, they need to be put in touch with some training resources. So that might look like Department of Services for the Blind, Department of Rehabilitation Services, or Department of Vocational Rehabilitation, or if your college has a disability support office that has an assistive technology trainer or somebody with that background, you would definitely want the student to get trained. And it sounds like Monica's back. So I'm going to Google pretext real quick and see if I can get a quick answer for you while we get the next question.
I'm back. Thank you, Zach and Don. So it looks like we still have the pretext question open from Elizabeth O'Neill, and the others have been addressed. So there's a few more. We'll go on to the next one. This resource from George Mason University indicates that Microsoft's equation editor, which produces OMML as a markup, is not accessible. Do you have comments on that?
Yes, my comment is no, no, no. OMML is Microsoft's proprietary equation editor format. And my understanding is that they've left that and they're using MathML now.
That's my understanding as well. So I don't think that article from George Mason is accurate anymore. Okay, next question. What if we post 2 versions of the same document, one PDF and one in Microsoft Word with MathML? Often the PDF is better for students who need to print it out.
Do you want to take that one, Monica?
So I'd say that, Zach and I are like our official stance for this presentation and a core tenet of accessible math is PDF is not the way to go. If you are able to, always include an accessible Word document with the accessible MathML that has the exact same content information in a PDF document, you're not necessarily going to be out of compliance for posting both. But I don't know if it's a practice I would generally recommend. They would need to be readily available at the same time. So the accessible Word document with MathML can't come after the PDF document. Zach, would you differ from my response? And that's okay if you would.
No, I agree. The only thing I would add is maintaining 2 copies of a document and making them be the same is twice as hard as maintaining 1 copy. And there is a chance that your accessibility checker will flag that as an inaccessible PDF.
Mhm.
So it might, if you're doing your PDF count survey for your institution and you've got a bunch of PDFs of math and you say, but I also have the Word document that's accessible, it's still going to count against you.
There was a follow-up comment from the person who asked that question. I use the MathML document to make the PDF, so they always get posted together at the same time.
Oh, then that's great. Yeah, that's probably a good
Workflow for that.
workflow. Yeah. I will address the pre-tech thing, and I'll say that it doesn't. I got some new information as I was sorry, I got distracted here. And also I was sighing earlier when Monica was talking because I was reading about it. This is in the category of a third-party tool. And I'm seeing a lot of stuff on their website from like 2013. And so we've come a long way in accessibility, and I'm sure it can output Braille, and it might be able to output standards, quote unquote. There were ways that we made math accessible before we settled on MathML from like 2015 or like 2012 to 2016 or so. It was kind of a really wild, wild west. So if you see older tools that are advertised to make accessible HTML or something, that's not the consensus that we've kind of now settled on. So I hope that's an answer. It might be able to do Braille though. That would be cool if it could do Braille. That would save it in my mind.
So Elizabeth and whoever else was asking about pretext, does that answer your question for now at least? I think I saw a thumbs up from Elizabeth. Okay, so I'm going to move on. And there's also some questions coming into chat, so we've got two places now to look at. Should we assume that Google Docs is not accessible since you haven't even mentioned it in this session? Hmm. Um, so I will say this, at our next session with Sean, part two, or no, excuse me, part three, he is going to be talking a little bit about Google Docs and math accessibility. However, the support for accessibility just really isn't there the way it needs to be across the Google suite. And that is a big bummer, big bummer, because I know that a lot of our, staff and faculty are using Google Docs in various ways. That is what I have to say. What would you add, Zach?
I I agree with Monica. And this again, if you see I'm not going to name any specific vendors or products, but if you see images of math with alt text, that's equivalent to asking someone to read descriptions of all of the equations in your math book.
So Um, I would say that presenting math and STEM in a Google Doc to your students, to your consumers is not what we are recommending. There may be some, some helpful information that comes to us in part three. But yep, that's how I think we'd answer that question. And the last one I see in the Q&A box is, this is also out of scope, but do you have any thoughts on using AI to translate handwritten notes into accessible documents? There was a question in the chat regarding handwritten notes. Okay, and I'm not sure what the question in the chat regarding handwritten notes was. Do you
Okay.
know what that was?
I'll just take this. I'm just going to say that I regularly use Olama to create accessible math for myself. And if you don't know what that means, it's out of the scope of this, but I think that it's a good use case and it's really out of scope, but I can't not say that it's a way to create accessible math. So, but it also can hallucinate. So that's all I'll say.
So I think we are acknowledging that there are positive use cases for AI in this space, and then but also having, checking the accuracy of the product, the end result from using AI is going to be critical from a subject matter expert before you assume it's accessible and, release it out there. Is that a fair statement, Zach?
Yes, and as long as the output is LaTeX or MathML, it should be good. I mean, it should be accessible. I don't know if it will be correct math, but this is getting into territory that's,
Yep.
yeah.
Okay. Let's see. I saw one about math type. So let's talk about that since we do mention math type in our presentation. The latest version of the math type added generates images with alt text. Do you know if it still has MathML? Oh,
Can you read that question again, Monica? I'm
yeah,
sorry.
sorry. So this person is saying they believe the latest version of math type is generating images with alt text.
This is a good topic. So you can set math type to do different things. And if this was out of scope of because this wasn't a session on how to use math type. But if you set math type to make images with alt text, images of equations with alt text, it will do that. And that, in my mind, is not acceptable. So what you need to do is set math type to create MathML. And there's a lot of rabbit holes here, but even when you export content from Microsoft Word, you should be using the math type exporter to export it, and you should be setting it to export the MathML and not the images of math.
For the person who posted that question, did you get your question answered? I'm taking no news as good news on that one. Yes, okay.
Cool.
They said yes.
Yes.
Great. Okay. So, we have about 5 more minutes for question and discussion. At this point, I'd like to invite you to unmute yourself with the question. I know we have a few unanswered items in the chat. If one of those was yours, feel free to, raise your hand or unmute now and we can have a discussion that way.
I'll take this topic about using LibreOffice or OpenOffice to do it, and it passes the accessibility check in Canvas. So that PDF that I demonstrated at the beginning of this session also passes the accessibility checker in Canvas. It says it's great PDF. So I don't know. I haven't tested LibreOffice or OpenOffice lately to see, but if it is exporting MathML and saving it in a format that most people can read, so HTML or .docx, it might be okay, but don't trust the accessibility checker to tell you that it's perfect.
Thank you, Zach. There's a question
Yeah.
in the chat that says, are you aware of any online graphing software that's tools like GeoGebra or Desmos?
I can take this because it's out of our scope, but Desmos is pretty accessible. And it has the ability to sonify graphs. It has the ability to output Braille. So as far as I've checked, 2 or 3 years ago, it was really accessible. GeoGebra is really, really not accessible. So it doesn't have a lot of those features that we would look for in an accessible platform.
Thank you, Zach.
Yeah.
There's a conversation in the chat about Equatio, but I think that that's been resolved within the Everett community. So I don't think we need to take that on right now. And yes, this PowerPoint and this recording will be shared out and posted to those of you who are asking. Let's see. Some of the remaining questions are specific to third-party platforms, and that's a little bit outside the scope of our presentation. So would you like me to share them for a very brief comment or leave it?
Sure,
Okay.
it's definitely up to you. I'm here to answer any questions.
I want to go there. Yeah, Don.
There's been a
Mhm.
couple of questions in the chat about sharing handwritten work along with accessible ML documents.
Oh, thanks, Don. Can you,
Um,
what's a specific question? I'm not seeing that.
so I'd like to share handwritten work along with accessible MML, math ML docs. Is there a way to make handwritten work accessible in a doc?
You want to take that one, Monica?
So I think, you know, in its very nature, handwritten math, in order for someone to access it, like handwritten math is gonna be it's gonna be a picture of math. So if you've got some handwritten math and you're sharing it with the student, probably you're scanning that into a document or you've taken a picture of that handwritten math and you're sharing it with students that way. So um, in its by its very nature, that is not going to be an accessible experience for someone who can't see the picture of the handwritten math. They're not going to be able to, you know, engage here and navigate that text. We've talked a little bit about how, adding an alternative text description to a picture of math is not going to provide an equitable experience. So you could choose to add an alternative text description of that handwritten math, but we've talked in this presentation that that's going to not provide an equal experience for the person who's listening, the alt text description. So really the math needs to be displayed for it to be accessible. It needs to be displayed using MathML, as we've been discussing and how we presented in that second demonstration that Zach did with his screen reader.
Yeah, I would agree.
So we need to so best workflow scenario for handwritten math would be to convert it into another output.
Yeah, the one kind of thing I would maybe add, but don't, is to consider the student needs. And so if you have one student who is a screen magnification user and she really likes your handwriting and you're going to write great so that the student can zoom in, and that's the one, like, you could consider student needs, but you do also need to remember that it's probably good to have an accessible equivalent of that handwriting in MathML somewhere.
Okay, one more question, and then we are near time. This one says, I make almost all of my course materials in LaTeX using Overleaf, which compiles and outputs a PDF. Am I understanding correctly that this is okay as long as I also include the LaTeX source code for students, since LaTeX is considered accessible?
Oh boy, I think I'm going to answer this and then Monica can, because we might differ on opinions. I think that in 2025, we've sort of settled on MathML being the accessible standard. Um, so what I would say is it's great for you to do that, and then maybe that makes it easier for your DSS office to make that LaTeX, or for you to make that LaTeX into MathML. The LaTeX is accessible, and it's also very trivially easy to convert into accessible MathML. So that's why I talk so much about it. But what say you, Monica?
So I have to admit that I don't have extensive experience with Overleaf, so I want to make sure I understand what it's doing correctly. And if, if I'm wrong, then I might not add much to this conversation. But what I think I'm understanding is that so so Overleaf is producing a PDF as the final output. Um, and this person is using LaTeX in Overleaf. So there's LaTeX underneath. Uh, but it's not generating MathML in the output, right?
That's also what I understand.
Okay. Yeah. Um, so it's great that there's the LaTeX there, but I would agree with Zach's comment that that end source file might not be accessible and usable to the student at the end of the day.
But it's trivial. I mean, it takes 5 seconds to make a LaTeX document into a MathML accessible document. So
So just do that one extra step and
yeah,
we should be good to go.
yes.
And then there's a comment about TextMake, but I'm not sure what that is.
Um,
Or TextMaker.
yeah, I'm not sure. This is the problem with all these third-party tools,
Yeah,
and we
there's a
need to
lot
talk
of
about the
it.
standard and not the tool. So if the tool that I've never heard of makes MathML, that's great.
Yep. Yeah. So I think what we're kind of getting to if we zoom out is the specific tools and workflow scenarios that you may find yourself doing could differ, right? Between you all as colleagues, but if the end game is accessible MathML, then we are generating something that's going to be accessible for assistive technology users,
Yes.
particularly screen reader users.
Yep.
Okay. It's 4:31 and folks are leaving the room, so I want to say thank you so much for to Zach for volunteering your time to do this
Yeah.
session with us. I count us
You're
lucky
welcome.
to have you in our system. And so I appreciate you sharing your expertise with us today. And thank you to our audience for your attention and engagement. It was really wonderful session.
Yes. I agree. And I want to thank everybody for their interest in making math accessible so that we can have more people with disabilities major